This will be a quick demonstration cut on a fiberglass insulation material. This is a rigid bat material. It's about 3 pounds or so. I think about 4 foot by 2 foot, 2 inches thick, foil faced, 3 pound per cubic foot. I have a potential customer who wants to turn giant piles of this into giant piles of this, roughly 1/4 inch or exactly 1/4 inch thick slices from the parent block. They're looking for a relatively low investment way to do this. The right saw for that job is our model 480P horizontal saw with the blade return underneath the table. I don't have that available. What I do have is a model 480i. This is a much larger, more expensive saw. The blade return here is above the table surface. But we're going to make this work. So the idea here is we're setting the blade at a 1/4 inch above the table surface. Table's fixed, table doesn't move. So we're going to slide the workpiece across the table to make the cut. A couple of things that I'm having to modify for this application. First off, this material is very light. For the first couple of cuts, that doesn't matter. But when we get down to the last couple of cuts, where I've got less than 1 inch thickness of material, it's just so light that the bandsaw blade wants to float the material around, and I can't get a straight cut because the material isn't staying down the table. My answer to that is put a weight on top of it. So this is just a piece of 12 gauge with a magnet as a handle. There's probably better, more elegant ways to do it, but we have a lot of steel around here, so this works out nicely. The other thing I'm doing first what I'm going to do, I'm going to run these across, I'm going to make life hard on myself. I'm going to run these 4 foot by 2 foot sheets across the 4 foot way. It would be much easier to run it through with 2 foot of material touching the blade, but I'm not here to do easy. So we're going to run it through with 4 feet of material touching the blade, like this. I'll get the first piece started. Then I'll use a second piece behind it to push the first piece. And in a high volume application, you'd have a big stack of these things here, and you just 10, 20, however many pieces, and you just keep pushing them through, using each following piece to shove the first piece through all the way. You don't want to watch this video for the next hour. So instead what I'm going to do, I'm just going to use 2 pieces and run them through and through and through, and I'll be shaving a 1/4 inch off the bottom every time. But to push the second piece through, I'm going to use a piece of foam. Serves as a pusher box. So what you do not want to do is try to use your hands or your finger to push through the workpiece through that fine little bit of cut, because fingers are expensive. Foam is cheap. So I just use this piece of foam as a pusher block there. So this is the first time we've done this. It may look a little awkward, particularly since we're just doing 2 work pieces. This would be better, be more efficient if we were doing a giant pile of work pieces. So if this looks convincing, I'll post this video on the internet. If it doesn't look convincing, I'm going to delete the file. You good? Okay. Rick here is going to help me out. One last point, the blade we're using is a 1 inch wide scallop edge style blade. It looks like a bread knife, as you might have at home in your kitchen. It leaves a beautiful dust-free cut. But it also makes it more challenging because the scallop edge blade does not carve out a channel of material. It just parts the material. Makes it much more susceptible to having the machine set up just perfectly. if we were using a hook tooth style blade, such as you might use to cut wood or metal or something like that, or plastic, it'd be much easier to get a straight cut. But I'm not here to do easy. So if I can do this, then a hook tooth blade is gravy, but it will also leave a bit of a furrier edge. Okay, let's talk more cut. Clear? So, I'm going to use my little weights here just to help hold the workpiece down. We'll set the cut pieces on one side. Thank you, sir. Got it. We'll just keep doing this for a bit. How do those cut pieces look, Rick? How do the cut pieces look? They look good?
Yeah, they're good.
Looks like this is probably the last one we get out of it. I'm going to push these through one at a time. They're getting so thin, I'm worried about it buckling up as I try to push it through. Yeah, we're shaving this one. Too thin. Might get one more out of that one. Let's take a look. Thank you. Let's see what we're getting here. A couple other quick notes here. You notice when I hit the stop button, the blade stops, boom, done. That's because we use a brake motor. It's a much safer way. And then I'm using gloves. Normally I advocate against using gloves when working with a bandsaw. The idea being that the hook teeth might grab your glove, pull your hand in. The scallop edge knife style blade will not grab a glove, and this material is just itchy, so I don't want to touch it. That's the last piece we didn't cut. So here's what we got. It's not perfect. We got some variation on this. And trying to measure insulation with a pair of calipers is ridiculous. Getting anything closer to, say, a 1/16 of an inch. That's like 0.22. Got a little thin on this corner. 0.20 or a little less. Quarter. 0.20 or a little less. So call it plus or minus a 1/16, but we're cutting 3-pound insulation, and it's kind of ridiculous to try to measure this down to 5 thou. I will follow this up with another video where we will cut thicker pieces and use a hook tooth style blade just for the compare and contrast. But in the meantime, I thank you for watching. If you have any questions, please feel free to call or email us at Forest Manufacturing. Thank you.